Hey everybody, this is Mrs. Kolonicki. Sorry, Ms. Viceno and I are missing out on seeing you guys today during class. We're actually at a workshop right now learning how to do some fun and creative things in math with you. Right now, I'm going to be reviewing this whole review sheet. Feel free to fast forward to any part that you have additional questions. I'll be explaining anything and everything on this worksheet. So here we go. First step says, use the word bank to identify the properties shown. Okay, we have the commutative property, identity property, inverse property, zero property, distributive property, and associative property. Number one is the associative property. The 13 in this is associating with 9 on one side, and then it's associating with 4 on the other side. Notice that the numbers 9, 13, and 4 are in the same exact order. Nothing changes. The only thing that moves is the parentheses. Number one, this associative property also works with multiplication as well as addition. Number two is the identity property. It's actually the multiplicative identity property, which basically means if I multiply any number by 1, I'm going to get that same number again. So talking about identity staying the same. Number 3 is the zero property. Any number times 0 is going to be 0. Number 4 is one of our inverses. It's actually the multiplicative inverse. If I multiply anything by its multiplicative inverse, also known as its reciprocal, I would get 1. We use this property specifically when we are dividing fractions. We multiply by its reciprocal. Number 5, again, I have a letter A that it's saying exactly the same. That is the identity property. This time it's with addition. When I add 0 to any number, I keep the same number. Number 6 is the inverse property, this time of addition. The additive inverse, when we add the opposite, when we are doing any kind of subtraction problems, we change it to an adding problem by adding the opposite. We're using the additive inverse or opposite. Number 7 was a little tricky, but it actually is the identity property. 5 plus 6 stays exactly the same when I multiply it by 1. So there we go. Number 8, I have 7 times 6 equals 6 times 7. That is the commutative property. A clue for commutative is changing order, CO, at the beginning of commutative. Change order, commutative property. Number 9, the distributive property. It's when I take a number on the outside of a set of parentheses and I multiply it by every component that's inside the parentheses. That is the distributive property. It is the only property that has two operations mixed together. If you notice, all the other ones have adding or just multiplying. This one actually has multiplying and adding or subtracting together. So that's the only one that has that. Okay, again, any questions? You have notes on these, so go back and look. It was probably the first day of notes. Okay, next number. We're at number 10, which says evaluate each expression. If A is 10, B is -2, E is -6, and F is 1. Evaluate means find the value of. I know, I'm writing on the board. It's crazy. All right, so letter A is 10. So I'm doing number 10. Here we go. Again, we're putting things in parentheses as we substitute. Sorry for the sloppy handwriting. I am just using a mouse. My mouse is not very clear when I work on this board. Plus F. So I'll do the plus F at the end, but it's just plus 1. So the first thing I'm going to do is I'm going to multiply 10 times -2 times -6. I'll probably want to do -6 times -2 first, just because, I don't know, I think those are smaller and easier to work with. So I'm actually going to get positive 12 when I multiply those two together. Right there. Alright, now I can add the plus 1, it'll fit. 10 times 12, again, I can do pretty easily in my head. I do 12 times 1 is 12, and just add the 0. And finally, adding on that last one, following PEMDAS, with multiplying being first, my answer is 121. Second question, again, substituting in -6 for e using parentheses. PEMDAS tells me I have to do this multiplication first. -6 times 5 is -30 minus 2. This is that issue that we talked about before. We're using our additive inverse. We're adding the opposite. This becomes -30 plus -2, which very simply, our same signs add rule, becomes -30. The next one, with an exponent, becomes a little more complicated unless the negative sign is in a set of parentheses with the a, like this. -a close parentheses squared. What you're going to do is you're going to take the a that they give you and put it in parentheses and leave that negative sign on the outside. So don't put that negative sign on the inside of your. Same thing with this 3. This 3 is not going in the parentheses. It's staying outside. Alright, just switching up some colors. Alright, so 10 squared really means 10 times 10, which is 100. So my final answer after this part, following PEMDAS, is -100. Plus, I have 3, but times -2 times -2, which is +4. So now I have 3 times +4, which is 12. And when I add that on to -100, I'm going to have to different sign subtract it. On the side, I actually did this work. You should do it too, because I did not just get that number in my head. -88. And the final one's going to be a little crazy to write, but we'll try my best to fit it on the screen for you. Because there's really no timesing, I can probably do this without too much craziness. Oh, except this double sign situation right here. I'm going to have to put -2 in parentheses. Plus f divided by e plus b. Oh, another double sign. Alright, that's really the only time I'm putting these guys in parentheses, is if I'm timesing, like I did over here, right here. Or, in this case, because I have double negatives, it's a little crazy. So, I'm going to change my pen color so you can see what I'm doing now. Specifically with this one, again, I'm going to add the opposite. So that is 10 plus +2 plus +1. Oh, that makes the numerator pretty easy. That becomes 10 plus 2 is 12, plus 1 more is 13, over -6 plus -2 makes -8. We're talking about same signs add. And if you want to change this into a mixed number, it would actually be -1 and 5/8. We want to reduce it. So there we go. Okay, on to the next section. Number 14 says simplify each expression below. Again, the words you have heard Ms. Fasano and I speak about many, many times. I'm just going to type it because it's just easier. Is combine like terms. And all that means is to add things that are alike. Like terms have the same letter or variable and the same exponent. So 7b and -2b are alike. I'm going to combine them by adding. Again, combine means just add. There we go. So 7b minus 2b is 5b. Then I have, I'm going to change colors so you can see what I'm up to. Then I have 9b squared, and I have a positive 8b squared. And together that makes 17b squared. Oop, I should make this a positive because it was positive, 5b. And then that 16 has nowhere to go, so that I'm going to keep it negative as it is right now. And I'm just going to bring it down. The reason I write it in this order is, again, just descending order with the highest exponent first, b squared, followed by b, followed by my constant, or number that stays exactly the same. If you were in a different order, would it be wrong? No. Just get into the habit of doing it with the higher exponent first. All right, number 15. Again, like terms, I want to circle them or box them or square them. Up to you, but make sure you grab the signs in front of them. This is 6 and 8/10 A plus 5 and 1/10 A. Again, doing the adding on the side, same signs add. And I get 11 and 9/10 A. Again, I'm adding on the side. You're not seeing me. I have the work and it's on the side. So be aware of that. I'm not getting these out of my head. The second two terms I need to combine is negative 2 and 4/10 and negative 7 and 42/100. Again, those are same signs. I'm going to have to add them. I'm going to show you the work that I had on the side. Lining up my decimal points. I'll add this 0 just as a placeholder. To add them, I'm going to get 9 and 82/100. And because those are same signs, my final answer actually will have a negative 9 and 82/100. So there we go. There's my answer. And the last one in this section is 5z plus 21 minus 2z minus 12. Like terms here are 5z. And again, circling that negative sign in front, negative 2z. Those are different signs, so I'm going to subtract and take the sign of the larger value. And the last one, positive 21, negative 12. Those are different signs, so I'm going to have to subtract them. Again, I did it on the side. 21 minus 12 gets you 9. It's going to be a positive 9 because 21 is bigger. And again, cannot do anything else with these answers. So if you're just getting one number as an answer, you're wrong because you're not combining the like terms. You're combining everything. And not everything can be combined. Alright, moving on to the next section. These are a little more complicated only because they're binomials. These kinds of questions, specifically the adding ones, are no different than what we just did. The only difference that you visually see is parentheses, and we know that these really don't mean anything. I could really rewrite it with absolutely no parentheses whatsoever. But because they're here, I'm just going to not bother rewriting it. I'm just going to work with what I have. That's 6x, and we're going to assume this is positive. I'm going to draw the 1 in there. So it's positive 1x. 6x plus 1x makes 7x's. The other parts to this is positive 7 and negative 7. Those are different signs. When I subtract them, I get 0. But I'm not going to write that in my answer. My final answer is just going to be 7x. What makes 18 a little more complicated is that sign right there. Just like we did with plain old integers, I am going to have to add the opposite. But remember, I have to opposite everything in the second term. So I'm going to rewrite this. 12 minus 4x plus negative 14 minus 8x. Again, do not do double signs where it says 8x. It should not say minus negative 8x. It should just say minus 8x. Now, combining the like terms, I'm going to circle the 12 that's here and the negative 14. Those are different signs. I'm going to subtract them. I'm going to get negative 2. And then here, I have a negative 4x and a negative 8x. Those are same signs. I'm going to add them. I'm going to get negative 12x. So this whole thing, negative 12x minus 2 is my answer. If you wrote it a little bit backwards, meaning you just took the components and switched them around, that's technically correct as well. So don't be concerned. Last one, same thing. No complications with these addition problems. Just circle and combine the like terms. 8 plus 3, that's positive 11. I have a positive 2x and a negative 6x, different signs. I'm going to subtract. Take the sign of the larger number. Final answer, negative 4x plus 11. Again, any questions, go back and look at, we've done a lot of adding and subtracting polynomials. These are there, they're practiced for you. My recommendation is go back and redo some of the problems you have the correct answers to. Or check my website out for more information, more practice problems, more games, etc. Moving on to the next section, using the distributive property to rewrite these problems. When you're talking about distributing, just like Ms. Fasano and I distribute handouts, you're talking about giving stuff out. When we learned this, we learned about how to draw these kinds of arrows to help us remember. And this operation is always going to be multiplying. So I'm going to be multiplying 6 times negative 8x, and I'm also going to be multiplying 6 by negative 3. So start with 6 times negative 8x. I will get negative 48, and just stick an x next to it. And again, I'm treating this sign in front of the 3 as a negative sign. So 6 times negative 3 will get me a negative 18. And that negative will serve as my minus sign in between the two terms. So do not write double signs. Use the sign that's there to multiply, and then use the sign as your symbol in between the two terms. Next one, 3 times 12, that's 36. 3 times negative 4x, negative 12x. Sorry, the handwriting's terrible. It's getting worse. Next one, 2 times x is just 2x. And then we have 2 times 15. If you have to do it on the side, do it. You actually get positive 30. And again, that's why I'm going to leave that positive sign there, because it's going to serve as my plus sign. And last but certainly not least, negative 4 times x, negative 4x. And negative 4 times negative 7, same signs, positive. You're going to get a positive 28. Again, check your rules for adding, subtracting, multiplying, and dividing integers. If I'm multiplying, the same signs will get me a positive answer, and different signs will get me a negative answer. That's for multiplying or dividing. Those are the rules. So be aware of those rules. And again, use the sign that's inside the parentheses with it, negative 7, to multiply when you're multiplying outside the parentheses. Moving on. Word problems. Here we go. I'm going to read it out loud, and I'm going to highlight some key words. The table below shows how much Laura spent on school supplies. How much more did she pay for the backpack than for the notebook and the calculator? Alright, so here we are comparing how much more for this than that. So I have the backpack, and then I have these two kind of together. So I want to know how much more she paid for the backpack than she paid for the notebook or the calculator together. So if I had to write a really big problem, I would have to write this backpack price first minus the notebook and the calculator together. Now I can do that if I want to. I'm just going to write it all inside this set of parentheses. And there we go. So the notebook and the calculator means I need to add these two guys together first. Again, they're inside of parentheses, PEMDAS, that goes first. So let's combine some like terms. And this guy makes -1. Ooh, sorry. It's hard to see my mouse on this thing, so there we go. Ooh. I'll rewrite. Alright. So I just found out the price of the notebook and the calculator together. That's 13x minus 1. So now I have to figure out how much more the backpack was than these two guys combined. That's going to require a little bit more work because of this sign right here. I'm going to have to add the opposite. 8x plus 15 plus negative 13x plus 1. So again, this positive 13 here becomes negative 13. This minus 1 becomes plus 1. All right, now, again, one more time, combining like terms. I have 8x and a negative 13x. Different signs. I'm going to have to subtract. Take the sign of the larger number. And positive 15 and a positive 1. Luckily, those are same signs, so I can just add them. And I will get 16. Because it's a word problem, I'm going to have to label it somehow, Because they're talking about how much did they pay, I'm going to assume I can just put a dollar sign here and call it a day. That's my label. So negative 15x plus $16. There we go. Again, when I'm comparing how much more, how many more, that is a subtraction problem. But you may be expected to subtract more than one thing, so just be prepared for that. Number 25. Jill paid 8x plus $12 for a new hat and 6x minus 10 for new gloves. Write an expression for the total amount she spent on the new items. There's my clue word, total amount. I want to know how much she spent on everything. So I'm just going to add those up. We learned two ways to add. We learned vertical and horizontal, so don't feel like you have to be stuck on just one of them. Sometimes, especially with multiple items, I'll add them vertically if I think that's easier sometimes, and sometimes it is. All right, I'm just going to add straight up and down. These guys are different signs subtract, so I'm going to subtract them and get 2. That 2 will be positive because 12 is larger. 8 and 6 are like terms. I'm going to add them because they are same signs, and I'm going to get 14x. Again, word problem. It's talking about money, so I can add and find the total this way. If you really wanted to, again, you could always go horizontal, but your answer will be the same. So again, it's up to you. Moving on to number 26. Eddie wants to buy 3 flash drives. Okay? If each flash drive costs $16.30, how much will it cost him to buy all 3? Justify your answer using the distributive property. That's kind of important. How much will it cost him to buy all 3? So he wants to buy 3 flash drives. Each flash drive costs him $16.30. All right. So to find the price of all 3, I would have to add $16.30 3 times. Faster way to do that is just 3 times $16.30. Now, distributive property, technically, we need something to distribute the 3 to. I don't have that right now, so I'm going to break $16.30 into 2 separate pieces. I'm going to separate it $16 on this side and 30 cents on the other side. So I'm really just breaking the dollars and the cents up. Nothing too complicated about that. Now I'm going to distribute using what they're asking me to do is using the distributive property. Now 3 times 16 I might have to do on the side, and that's okay. I actually did have to do it on the side. You get 48. So this part of my problem will be $48. 3 times 30 is going to be a little bit less complicated because 3 times 3 is just 9. So I have 30 cents times 3 is just going to be 90 cents. And when I distribute, I always keep the same sign unless my multiplication makes it negative. So my final cost for this, without doing too much complicated math, is $48.90. You can do it just by multiplying 3 times $16.30, but the question is specifically asking you to justify using the distributive property. So you have to have this step in here. You cannot just multiply 3 times $16.30 and get $48.90. Doesn't work. They're asking you to do it a specific way. You're going to be expected to do this on your test. Next question says, Eddie wants to buy 9 ice pops. Each ice pop costs $2.18. How much will it cost him to buy all 9? Again, justify using the distributive property. Each ice pop costs $2.18. I want to buy 9 of them. All right, so again, just to find that answer, I would have to do 9 times $2.18. But again, that doesn't use the distributive property. So I'm going to break up the $2 apart from the 18 cents. So now I can distribute 9 times $2. That's pretty easy. That's just $18. Some good mental math. 9 times 18, not as easy. I actually had to do it a little bit of work on the side, and I'll do it for you right now. 18 cents times 9. 9 times 8 is 72. 9 times 1 is 9, plus 7 makes 16. And just like we learned from decimals, if I have 2 decimal places in my problem, I need 2 decimal places in my answer. So that final answer for that multiplication is going to be $1.62. But doesn't make the adding too complicated. $18 plus the $1.62, $19.62. Again, if you get stuck on this, you can always find the answer to this. You can always do this math and get 1962. So if you're ever confused and you're not sure if you got the right answer, you can check it. But this is what we want to see. We want to see you showing the distributive property. And really breaking $2.18 up however you want to do it is fine with us. You can break up, you can $2.10 and 8 cents here. But this, I think, is the easiest way to do it. And the final 2 questions, here we go. A gym charges $75 per month plus a $15 membership fee. Write an expression. Okay, I have to write something that gives the total cost in dollars for having a gym membership for M months. So they're telling you what variable to use. They're telling you need to use M. So I'm going to start with that part of the question. I'm going to go back and reread one more time. So the gym charges $75 per month. As soon as I see where it says month, I'm going to put the letter M. So when I write this, $75 per month, that's where the M is going to go. This is part A, write an expression. Plus, it even says it for me, wow, plus a $15 membership fee. So my final cost for M months is going to be 75 times M plus 15. Part B now says, well, okay, using this, find the total cost of the gym membership for 8 months. So I'm going to have to do 75 times 8 plus 15. This is very similar to what we did with evaluating. On the side, I did 75 times 8. 8 times 5 is 40. 7 times 8 is 56, plus 4 makes 60. So this is $600, plus the 15 for just the membership fee, for a grand total of $615. But again, this was not my only answer. This was also an answer. I had to write an expression, and then I had to find the total cost. So again, going back to make sure I read, I did everything the problem asked me. Some of these will ask you for more than one step. And final question. The Sweet Tooth Candy Shop sells fudge for $4 per pound and licorice for $3 per pound. Write an expression, okay, to find the total cost of purchasing F pounds of fudge and L pounds of licorice. Okay, so if I buy F pounds of fudge, the fudge, it's right here, is $4 per pound. So I have to stick my little F right here. $4 per pound. And the licorice, there's my licorice, is $3 per pound. So again, my L is going to go here. I'm going to use a script L just so it doesn't look like a 1. So it's going to be like a little loop right here. And I want the total cost of purchasing the fudge and the licorice, so I'm just going to put a little plus sign there. And that looks like it. Write an expression to find the total cost. There's my fudge, there's my licorice, I'm done. That's an expression. If you have any other questions, I hope that you check out the website. You can ask us in class. We'll be in class on Friday, but we do have a workshop today. Any last minute questions, feel free to ask at the beginning of the period on Friday. Otherwise, please check the website. I do have a video that goes over a bunch of stuff, so check it out. Thanks, guys. Have a great day.